How to create a Seaborn correlation heat map. In our earlier lessons, we have learned how to generate heat maps using Python's Seaborn library. In this lesson, we will learn how to plot correlation matrix using Seaborn. So, what is a correlation matrix? A correlation matrix is simply a n-by-n symmetric matrix that displays the correlation coefficients for different variables. Large values in the correlation matrix indicate strong collinearity between the variables involved. A correlation matrix helps us to understand whether a set of variables correlate with each other or not, and whether that correlation is positive or negative. In this lesson, we will learn how to calculate the correlation coefficients for a number of different stock prices by downloading the data from online sources. But before that, let's understand how to calculate the correlation coefficient of just two variables. Let's start with a simple data frame with just two variables cost_count and sales. Here the data is for 7 consecutive days. Let's display the data frame. So, these are the customer counts and corresponding sales figures for 7 consecutive days. Let's calculate the correlation coefficient for these two columns of the data frame using pandas core function. As we can see, the correlation coefficient of cost count and sales is 0.969, that is, nearly 1. So, there exists a high positive correlation between cost count and sales amount. Let's plot a regression line using Matplotlib and Seaborn library. We will use the Seaborn's regplot function for this. We need to pass the data frame and the x and y variables to the regplot function. Let's use cost count as x and sales as y. This is our complete code for calculating the correlation coefficient between cost count and sales, and plotting a regression line. And here is our regression plot. Positive correlation is clear from the plot. Now let's plot a regression line for this new dataset. Here the columns are temp, that is temperature, and sales. Here sales figure is for the sales of winter clothes. Let's modify the code for the changed dataset. And here is our regression plot. Notice that the columns have a strong negative correlation. I forgot to display the correlation coefficient. Let's display it now. As we can see, the correlation coefficient is -0.9429, that is, nearly -1. Let's again modify the code with new data frame. In this case, the sales figure is for salt, an essential commodity, and its demand is not dependent on temperature. As we can see, the regression line is flat. It indicates that the sales of salt is not dependent on the temperature. Look here, the correlation coefficient is just 0.1, which is nearly 0. I hope that you have understood the concept behind the correlation coefficient. Now let's move to the higher level, that is, creating a correlation matrix of more than two variables. In this example, we will create a data frame from a CSV file. The CSV file holds the closing prices of a few stocks listed in various stock exchanges. These are the closing prices of the stocks SBIN, PNB, BAC, WFC, etc. Let's start coding again. Just follow me along while I code. I will explain wherever required. Creating a data frame DF from the CSV file stock_prices.csv. Here we will use the date column as index of the data frame DF. Let's have a glance at the data frame so created. As we can see, the data frame has 258 rows and 10 columns. Let's drop the rows that have NaN values using the drop_NA function. Now the number of rows is reduced to 237 from 258 earlier. Now let's calculate the correlation coefficients of all the combination of stocks using the CORR function as a matrix. This matrix is known as a correlation matrix. Let's display the correlation matrix CORR_DF. The matrix is stored as a data frame. So, we have got a 10 by 10 matrix. This is because we have 10 stocks in our data set. These are the correlation coefficients of each pair of stocks. Let's enlarge the screen and see the matrix clearly. As we can see, the correlation coefficient for PNB and SBIN is 0.711. For HDFC and SBIN, it is 0.236, and so on. Now let's plot a heat map of this correlation matrix using Seaborn Heatmap function. And here is our correlation heat map. Interesting, right? So, we have successfully plotted a correlation heat map of stock prices from a CSV file using just a few lines of code. Now we will use the yfinance, that is, Yahoo Finance library for downloading stock prices. If this library is not installed in your system, you may install it using pip install yfinance. Like before, just follow me along while I code. I will explain the codes wherever necessary. We want to download the stock prices for the date range January 1st, 2023 to December 31st, 2023. We will use the yfinance.download function for downloading the stock prices for a particular stock. The downloaded data can be saved as a data frame as shown here. SBIN.NS is the ticker name, the date range is mentioned using the start and end parameters. Let's first view the data frame SBIN_DF to check the columns and the data. As we can see, the data frame consists of 245 rows and 6 columns. The column names are open, high, low, close, adjusted close, and volume. We need only the adjusted close column. So, let's download the data for this column only. Now we have only the adjusted prices for various dates. Here date is the index column. In this way, we can download stock prices for any listed stock. Now let's create a list of tickers of our interest. We will use this list for downloading the adjusted close prices of these tickers in one go. Let's modify the code for downloading the prices for all of the tickers as per our list. Here, instead of a single ticker, we have supplied a list of tickers to the download function. Now our data frame stock_prices holds the adjusted close prices of the tickers mentioned in the list stock_tickers. Our data frame is ready. We can use this data frame for any kind of calculation and plotting. Let's modify the list of tickers. Now we have 10 tickers. Let's clean the data frame by dropping the rows with nan values. Now the data frame has 237 rows. Now let's create the correlation matrix of the stock prices. And here is our 10 by 10 correlation matrix. Let's plot this matrix as a heat map using Seaborn. And here is our heat map against the correlation matrix of the adjusted closing prices of the stocks. This is very basic. We may format this plot with other parameters. Now we will modify this code for generating a heat map against the correlation matrix of returns of each stock. We will also format the plot for more beautiful appearance. This time we will plot the correlation matrix of the daily returns of the stocks. Let's plot the heat map with a few other parameters. Let's assign the axis object to the variable AX. Now let's give a title to the plot. Increasing the font size for the plot. set the background style as white. Let's format the numbers with 2 decimal places. And here is our final heat map. Isn't it beautiful? You may format this plot with many other ways for making it more beautiful. Here is our complete code. Hope that you have enjoyed this lesson and learnt many new things. If you find this lesson helpful, please don't forget to like, share, comment, and subscribe. Your valuable feedback is important for me and will help me improve the contents of the channel. Thanks for watching up to the end. Hope to see you in the next. Bye.